Lesson 35-2 is going to talk about volume of pyramids and cones. Okay, so we are in our Springboard book today, starting on page 513. Okay, so we're going to start by looking at this picture here. It says, for a new package design, the packaging engineer needs to confirm it can meet the volume requirements for the product. Remember, volume means how much we can fill up inside of the figure. Okay, so consider the three the potential package designs below. Each pyramid has the same base area and the same height. So we have three kind of oblique pyramids here, but they all have the same base and the same height of the pyramid. Okay, so when packaging engineers manipulate the pyramid into the figure shown, what figure do the three pyramids form? So if we put all three of those pyramids together, and they're kind of showing you here, we put all three of our pyramids together, what figure did it make here? Hopefully you noticed that made a cube. Okay, so if we put all three of our pictures together with the same base and the same height, they should piece together to form a cube. Now we already know the volume of any prism, rectangular prism, square prism, okay, is big B times H. The area of our base times our height. Okay, so if we think of this, how many pyramids formed this cube? Well, we know that there's three pieces, right? And what we know about each pyramid is that they do have the same volume. Remember, they said they all had the same base. And the same height. So when we talk about the volume, they should all be the same. Okay. So what we're going to do here, it says describe how the formula used in 2a, big B times H, can be adapted to find the volume of just one of our square pyramids. Well, if it's big B times H, and there was three of them, here's our formula. So the formula for a square-based pyramid is big B times H divided by 3. Now we have this Cavallari's principle here on the bottom here that says that any two objects with the same height in the same cross-sectional areas at every height have the same volume. Okay, so when we're talking about question 4 here, Keith states that the formula in 2E does not apply to a pyramid with any polygonal base. Angela says it does apply. Okay, who is right? Would be Angela. Okay, because this principle states that the formula is valid for any pyramid. Okay, used for big B does change because the base of the area can be different. Okay, so we're always going to use big BH divided by 3. This will always work for any pyramid. But again, what changes is big B, because we could have a triangular base, we could have a rectangle base, we could have a hexagonal base. The base can change, big B, but this formula, big B H over 3, will always be our volume formula for a pyramid. Okay, so let's do some examples here. On the next page, we says, remember our volume, I'll write the formula up here. Volume is big B times H over 3, so divide by 3. So I'm going to have you guys just try A, because this one's just plug and chug. It says the height of a pyramid is 24 feet. The area of the base is 22 feet squared. Compute the volume of this pyramid. Okay, so plug and chug that into your formula that I put on the right there. If they gave you the height and big B, it should be easy to just punch in your calculator. Okay, so find the volume of that pyramid. Okay, if you did it correctly, you should have 176 feet cube. Remember, volume is always in cubic units. Okay, the next problem is going to be more of an application problem. This time they're giving you the volume of a pyramid. So they said the volume of a pyramid is 220 cubic centimeters. The area, the base area, so big B, is 10. What is the height? Again, use your formula, plug in what you know. This problem you're solving for the H. So see what you get for H. Okay, if you did it right, you should have got 66 centimeters. So here's my work, in case you want it. Okay, so what I did is I multiplied the 3 out on both sides. And 220 times 3 should give us 660. Divide that by 10, and you've got H by itself. Okay, the next problem I'm going to help you guys with a little bit. It says the slant height of a square pyramid is 10 feet. Okay, so if I go to this picture up here, remember slant height is referring to from the vertex down to the base edge. That's our slant height. We called that L in our previous videos. Okay. So for a square pyramid, we have a base pyramid. Our lateral face, okay, is going to be a triangle. So for this problem, I just went ahead and drew a triangle here for our sides. Now, if we have our slant height, they're saying the slant height is 10. Okay, one of the bases is 12 feet. But in order to find the volume, we need big B times H. So essentially, we need the height. We need to figure out the H. So let's look here. If this is 12, that makes this little piece 6, right? Because it will drop it perpendicular and cut it in half. So I'm going to have you guys find H for me. Remember, now this is dropped at a perpendicular right angle. To be the height, it has to be perpendicular. So we do have a little right triangle there. So if one side is 6 and your hypotenuse is 10, what's the height? Okay, we should have got that the height was 8 feet. Okay, so now that you know the height, you know it is a square pyramid, square, with a base of 12. I'm going to have you guys finish it. Find the volume for me. Okay, the volume should have been 384 feet cubed. Okay, 12 squared would be 144 times your height, 8. All right, we're going to move on now to our cones. Okay, the volume of a cone. Now we're going to skip all this springboardy stuff, and I'm just going to jump right down the bottom here to question 9 and give you the formula. Okay, so to find the volume of any cone, essentially it's the same formula. It's big B times H divided by 3, except for a cone, big B is a circle, right? So that's why it's pi r squared. So again, it's the same formula for a cone in a pyramid for volume. In this case, you're just changing out what big B is. Okay, big B is a circle. So I'm going to have you guys try number 10 here. Compute the volume of the cone if the radius is 6 centimeters and the height is 15. Again, volume for a cone is pi r squared times the height over 3, divided by 3. So I'm going to have you guys do this in. It says round to the nearest 10th. Okay, if you got the answer right, it was 565.5 centimeters cubed. Okay, so if your answer is close to that, depending if you use the pi button or use 3.14 for pi, you could be off by a little bit. But okay. I'm just going to have us wrap up one more and do problem 14. It says a perfume bottle in the shape of a right cone has a diameter of 6 and a slant height of 5. So I went ahead and drew a right cone there. Okay, it's not a perfect right cone, but it gets the job done. So if we have a diameter of 6, that means our radius here is 3, right? And it said it has a slant height of 5. Remember, slant height goes from your vertex point down to the base edge. So slant height is 5. Now for volume, we don't necessarily need the slant height anymore. Pi r squared times h. We need h, the height. Okay, now again, we've kind of seen this happen a few times now. We have a right triangle there with one side 3, hypotenuse of 5. So find h, okay, and then figure out how much perfume can the bottle hold, aka volume, okay, to the nearest cubic inch, so round to the nearest whole number. So see what you get for 14. Okay, if you did this correctly, you should have gotten that the height was 4. It's a 3, 4, 5 triangle, so you could use Pythagorean triples or Pythagorean theorem there. So r squared, 3 squared would be 9. 9 pi times the height, 4, over 3. So I just simplified this to 12 pi, put it in my calculator. I think it was like 37 point something. So we round that up to 38 inches cubed. Okay. So again, we're going to practice more problems of volumes for pyramids and cones. But remember, it's big B, H all over 3.